Thanks very much, everyone, for your time and great presentation. Jeremy and I will hopefully do a good job in supporting everything that you've covered. So briefly, I'll put my LinkedIn details up. I'm Principal Consultant at Autodesk, focusing on construction line, all things construction, design for manufacturing, assembly, reality capture, cloud work sharing, etc. That's what I do on a day-to-day basis. Been around in the industry now for 30 plus years, qualified in Mech Eng, computer-aided design, construction management, and also did a lot of architectural design as well throughout my career. So that's me in a nutshell. For me, everything that Jeremy said rings true. So I deal with construction predominantly, and I work with a lot of the big construction houses. Safety, zero harm is the #1 goal on a construction site. So you can see here, this is a 360 pano that I took with my drone of a construction site, and it gives a great bird's eye view of the overall site. And using software, I can link that into ground-based videos, so I can put links in. So it ties all the information together, so it allows anyone that wants to review that project the ability to navigate from one scene to another. It is also fantastic for doing site inductions. For anyone that's done a site induction, when you're looking at a 2D plan, you really have very little understanding of that site in context, the sort of challenges you may face, the obstacles, obstructions, etc. Whereas if you can view that in 3D, you stand a fighting chance. So that's just one example. For me, I believe we've done building information modeling now for a couple of decades. I actually think almost a more important aspect is to create an accurate construction information model. You know, poor planning results in a lot of things like poor equipment siting, poor welfare, inadequate position for space, poor wayfinding. But the big one again is security and safety issues. Okay, updating that construction site on a weekly basis, if not sort of almost every other day, could result in a much more efficient construction site and a greater improvement in safety. Again, you know, in the UK, a lot of construction sites, you have people working from many countries that don't necessarily have English as a first language, and so looking at drawings and looking at signs that are in English may prove tricky. But you give someone a 3D model and they understand what's going on. So I'm all for this, and I'll show you a way that we can do that in a moment. Jeremy talked about the 360 cameras, and again, it's important of choosing the right technology, the right solution for the right reason. 360 cameras are super fast, very cost effective. You can have loads of people on the ground capturing the photos as they go. Great for progress monitoring, as-built construction, risk management, all of this kind of stuff. It's the fastest way of capturing information. Laser scanning, do a lot of that myself. I've been doing that for years. Very, very accurate. So if you want to do design versus as-built accuracy, then laser scanning is key for internals. But it is time consuming, not as time consuming as traditional survey methods by any means, but you're talking 4 to 8 minutes a scan. And then you have to stitch all those together, and it creates huge amounts of data that you then need to process. But again, right tool for the right job. Drones, love my drones. Been doing drones now for a number of years, certified pilot in the UK, commercial pilot. This is an example of a site captured 56,000 square meters in less than 20 minutes. Processing time was about 3 hours, okay? So in 3 hours, 20 minutes, I have got a model of that site, plus or minus with ground control points of 3 to 5 centimeters, okay? That is super efficient. The other thing is I don't have to be on site to do that survey. Okay, I can be outside of the site, therefore I don't need to do a site induction. I don't need to go through all the safety protocols and high vis or having someone, a responsible person, go around with me. I don't need a surveyor to go with me as long as I know where the ground control points are, so I can do it remotely. So it's not only is it time saving, but again, it's improving health and safety. And you can see the kind of the benefits there, the business benefits. So I'm happy to share these slides as well. So Jeremy talked about safety as well. So I've done some work recently with a company that does offshore wind. And again, you go up and you manually survey these blades for pitting. You're hanging off there in a harness. The safety aspect of this is immense. So is the time it takes to do this. With a drone, stand on the platform, up you go, do a vertical scan, 2 manual photos, site inspection, huge cost saving. So again, remote, fast, massive improvements on safety. Benefits of the drone deploy and software such as that as well is I can pre-plan a flight before I go to site. And I can actually simulate this to make sure that before I get there, it's going to capture what I want to capture. It also means that if I'm not actually doing the flying, I can hand over to another certified pilot and they can carry out the same flight again and again and again, capturing that same information on a weekly by weekly basis. And then we can start doing a comparison. So it's not manual control, it's pre-planned, which is great. You can do the, as Jeremy mentioned, the progress monitoring, you know, the difference between day to day or week to week, etc. I'll show that live in a moment. Validation as well, uploading the plans. So you have the drone, high-res ortho mosaic, you have a drawing, and we can combine the two and we can actually see whether or not what's been built matches the original design data, or if you've got underground services in this case, you can see where they're running into the 3D model, etc. Very quick to do site progress and analysis, such as volumetrics. You know, I worked with a company not that long ago where it was a sideline conversation. He'd been out on site surveying stockpiles manually. It's taking him hours and hours and hours, and I just showed him drone deploy and how quickly you can do this, and he nearly fell off of his seat. Literally clicking around an area and it generates the volumes for you. Cut, fill, net, volume, etc. You can then assign it a particular material, and importantly, you can instigate an issue and say whether something is incomplete work and it's open it when it needs to be resolved, etc. And you can push all that out as a report. It's fantastic. Design versus as built. Now, whether it's drone data or whether it's LiDAR, comparing the reality capture with the design intent and what has been built and overlaying it to see deviation. Again, very useful. We're going to have a bit of a conversation, I think, the questions about where the industry is going, but things like real-time equipment feedback and monitoring, so remote controlling of plant equipment, okay, real-time telematic feedbacks, this kind of stuff. Machine control, so driverless, the machine, you tell the machines what they need to do, where they need to do it, and away they go. This is all controlled. It's faster, it's more accurate, you've got improved operating costs, etc., etc. But I think, you know, where this is going to go is things like drones doing reality capture is going to start to feed back and update topography, and that is in turn going to feed back to the machine controls for sort of tighter integration and analysis. So I really think that's the way the industry is going to move. Touch briefly on the whole VR thing. So virtual reality is really starting to take off in a construction environment. At the moment, solutions out there really require meshes, but again, you know, through drone deploy, you can output an OBJ. If you download the point cloud, process it in Autodesk Recap, we can output as an FBX file format. And there's a number of solutions out there. You know, Unity Reflect is one example, where you can get the actual site model into a VR headset, and you can get everyone doing a virtual tour, reviewing, marking up, etc., without the need to go to site. So again, reducing expenses and improving health and safety. So I'm going to flip over and just show you a couple of live things. So this is just one example of a flight I carried out. You can see this is a site plan, an actual, well, construction site, and we have the site plan overlaid. And you can see here this catchment pond, completely different to the original design intent. I don't know why, but we can clearly see that if you were giving someone this original drawing and telling them where that is, and they were relying on that, you'd have a pretty big problem. Again, down here you can clearly see that this service road is not in the same location. Okay, the access is different. The buildings are looking pretty good, but this ability to overlay the CAD data and do a comparison and update, it's really, really powerful. Let's just go back to the projects and open this one up. This is that one I showed you earlier. So again, overlaying the CAD data, and we can see underground services and how they feed into. So you're looking at the high definition ortho mosaic that's been created with the CAD overlay going over the top. And I mentioned about these volumetrics. In the past, you'd have to go to site, you'd have to go through induction, safety, you might have to have someone go down with you onto site. They may have to stop work in order for you to access something to survey this area. But very easily, we can just draw, I'm just going to do it roughly around here, and voila, we have the volumes immediately. And I'm not joking, that could be saving half a day, if not more. And the software can actually monitor this and give you the changes on a day-to-day basis as well. So huge cost savings, huge impact on improving health and safety as well. The model itself, again, if I switch into here, it's producing this mesh. So it's processing the photos and generating this mesh, which I can download, and I can put it into my VR and walk around it and give people a true site walk down in context, as I said, with never having to step foot on the site, which is great. And we also have access to the point cloud information, which again I can download and I can reprocess in something like Autodesk Recap. And why would I want to do that? Well, I've scanned the internals of these buildings using traditional LiDAR, but I did not get up onto the roof. And to do the LiDAR of this roof, you'd either need to put scaffolding up, you need to climb up on top, but then you've got health and safety issues. You might get a cherry picker and go up, but it's expensive and time consuming. So what I can do is simply merge the drone point cloud with the terrestrial laser scan point cloud and generate a complete survey very, very quickly. This site, just out of interest, is power station. It's actually for the wind farm. So we're talking about incredibly high voltage going through here. Anything that happens on this site requires a huge amount of induction and safety, locking off areas, shutting down different zones. And to shut down a zone to carry out any form of inspection is incredibly expensive, as you can imagine. So once again, this was flown outside of the actual site itself, required no induction, it just needed approval to fly over, which we got. And again, bypassing all of that red tape in order to get this information, absolutely critical. So yeah, the combination of the drone deploy software and what we can do with it, there's a couple of things from the Autodesk aspect. So I've mentioned Recap Pro already for processing, but if any of you are using our cloud-based solution, BIM 360, great tool for working in construction. So it's a common data environment, it does field management, project management, model coordination, all of these things. It's where you host all your models, your CAD models, and your documents, Word documents, Excel spread files, photos, etc. But on the project homepage, this dashboard is customizable, and we have these things called partner cards, which I can go and add. And you can see I've added in the drone deployed partner card into this particular project and linked it to the drone deployed project for this site. And what that means is, as a user, I don't have to go out to drone deploy site and then back in. I can stay within one environment and I can access exactly the same information. So there's the 3D model. I can go and look at my annotations and my issues and turn them on and off. I can do my volumetrics. I can go and look at the map with the CAD overlay, etc. And this is really powerful for the users, as you can imagine. Now, I mentioned about creating a construction information model. Another piece of software which I think has huge potential within the construction industry is actually one of our infrastructure solutions called Infraworks. And Infraworks, again, I'll just quickly show you. Here you have a large area in the UK. This is generated from being an OpenStreetMap. So you can see the sort of aerial imagery. And if we zoom in, you actually have roads, which if I go look at their properties are, real roads. They're named, type of road, and type of vehicles and speed and all that kind of stuff. And you can actually do design work with this. But one of the things that this allows me to do, people were talking in the window about file formats. Infraworks allows me to bring in a whole variety of different file formats, including point clouds, meshes, land XMLs, IFCs. So you can see here, I've loaded in that same point cloud. Okay, so now we have a full contextual model going on in here, and we can do all sorts of analysis. This was actually done for working with the local council and also with the local residents from a certain distance around this area, doing lines of sight, what they were going to see, the impact on visuals and all of that kind of information. But Infraworks is really neat. If I go back out to here, you can see we've got a model builder. So very, very quickly, I can start with nothing and I can go in and type in a particular area around the world, wherever that is, zoom in, postcodes or whatever it is that you want to use. I can select an area and I can tell it to go and create the model. And that will go and do that in about sort of 10, 15 minutes. It will generate the model for me to start with, without me doing anything. And then it's down to me to start adding in layers of information over the top. And to give you another example, which was in my slide deck at the beginning, let's go and open up this one. This again is a real project. And okay, here we go. So I'm just going to go and switch to the master. So again, you can create different scenarios, as many scenarios as you want. This is what the Infraworks created with no input. So you get a basic terrain, you get basic shapes for buildings with the right height coming out of OpenStreetMap, and you get real roads that you can go and edit and stuff like this. But this is where the work was being carried out. It's on a fairly steep slope, new buildings, new residences going in. And what we did, and it made a massive difference to the entire construction process, is we went out on a weekly basis and we flew the drone, again, probably a 20-minute flight, 2 to 3 hour processing time. We bring in the point cloud into Infraworks, and the point cloud can be used to regenerate the topography. So instead of being points, being a point cloud, it's actually updating the Infraworks terrain accurately. And it's also laying the ortho mosaic over the top. So you get this very, very detailed construction model in 3D. Okay. It will also do feature extraction. So it can do linear feature extraction. So if it finds a road, a curb, a railway, if it finds trees or street signs, etc., it will actually convert those for you as well. But what we then did, you can see here, we mocked up the site cabins, we mocked up an access road, we've got the real design model starting to come in. Obviously this is just a structure, but this is accurately positioned. We were able to then locate the tower cranes, material handling areas, and do things like calculating line of sight as well, whether the lorries coming in were going around blind corners, what the gradient was, all of this kind of stuff. And this gave the workers during their regular meetings in the morning a much greater context to talk about potential issues, areas of concern over and above when they were working previously with just a 2D plan being marked up in a traditional way. So I don't know how I'm doing on time. I seem to have talked quite a bit. I think I'll leave that there. And again, I'm happy to take questions, Alex, and so forth. Hopefully that was a good brief insight